Hey everybody, Kit Merker here from Nobl9, and I'm joined by Niall Murphy, and we want to talk about machine learning. And in fact, a very specific part of machine learning. We want to talk about service level objectives for machine learning, or ML ops, as some people are calling it. So, Niall, what is this? What are we talking about?
Hey, Kit. Basic story here is running machine learning systems is pretty complicated. And what you tend to see in the industry is folks who are day to day acquainted with the details of constructing machine learning models are not necessarily day to day acquainted with what it takes to run production services. And so what you tend to see is folks who are pretty good with figuring out what the mathematics of a particular distribution is and how to construct a model when you've got the model kind of on the operating table and you're able to poke at the internals of it. But there's a similar effect that we sometimes see in the SRE community where folks who have a strong background in product development write a thing and then ship it off to production. And what happens in production is kind of magical mystery, and the details of how to do that in a disciplined and business friendly way aren't necessarily in everyone's background. So one potential way to address this is to bring the framework of thinking about service behavior, service level objectives, and bringing that lens to managing machine learning models in production.
Awesome. So we're going to see a demo of actually SLOs with the machine learning in just a second. And I want to come back to that, and I want to make sure the audience knows this is coming. So let's hold that. You're going to see a very cool live demo of this working. But before we get into that, let's talk about the background. So you talked about SLOs, service level objectives, SLOs. Maybe for the audience who maybe isn't familiar with that, can you just give us a brief tour of what are SLOs and why are they valuable for managing infrastructure?
Basic idea is to pick a target, right? To pick a level for a particular metric inside an application. Typically, actually, we would like that metric to be associated with good user outcomes or user outcomes in some sense. So if you have, for example, a source code control company and you're doing distributed source code control or version control or something like that, you would want to be looking at the number of successful user checkouts, the number of successful user uploads, changes, so on and so forth. So you can set acceptable, user acceptable and business acceptable levels of behavior on these user experiences. Now, the user experiences often don't relate just to one thing that's happening inside the software. You often have to aggregate a bunch of things that are happening inside the software, like writing files for the source code control or updating metadata or tickling the database or whatever. But the general concept is there's a bunch of these things and you try and map that to the user behavior. And the bit about setting the target in a way which we expect is going to be acceptable to the user and acceptable to the business in general. The magic there is that by not selecting something which is 100% kind of explicitly, you enable a bunch of better behaviors for the organization behind the scenes and also reflect the reality that a service which is available, 99.999% of the time, it's very hard to distinguish for most users from a service which is available 99.9% of the time or whatever. So you're building in organizational resilience and service resilience and also development resilience or velocity, I suppose, by picking these targets less than 100%.
First of all, machine learning is not perfect, and we've seen plenty of examples where artificial intelligence has caused mistakes, we'll call them, issues with categorization of images or recommendations, all the way up to not seeing the truck in front of it when it was supposed to apply the brakes in the car. So I think it's safe to say that today's state of machine learning and artificial intelligence is not perfect, and so it kind of fits with this service level objective concept, this SLO concept of we don't want to, we're not able to aim for 100%, and we're trying to set a different goal. Obviously, we'd like to work in those very critical scenarios better than others. And you're writing a book on this topic of machine learning or ML ops, right? Can you tell us a little bit about the book and how this is applying SLOs and other kind of operational SRE background you have to machine learning?
I have indeed. The provisional title is Reliable Machine Learning, which I expect will be the actual title. And it is due out, I think, sometime like May next year or thereabouts. I'm writing it with a cast of characters, some of whom will be well known to folks in the production engineering space, like Todd Underwood and myself as well. And some folks are well known in the ML space, a gentleman called Dee Scully, who comes from Google, and also a person called Kranti Parisa, who used to run some of the iTunes store and App Store kind of ML in Apple, although he's somewhere else now. And finally, Kathy Chen, also from Google. So we are basically trying to do for ML what the SRE book did for, I suppose, production operations in general, which is to put some shape and some frame on a set of practices in the industry, which are actually pretty Wild West. Right now, there's just a lot of, I guess due to our business priorities, we have to ship this thing really quickly, so let's ship it really quickly and come back and fix it later, said the optimistic engineer who is never going to come back and fix it later. So,
well, they just worked on a cool ML project, so they can probably get a new job anywhere they want. So that's somebody else's problem.
Yeah, well, like being in the middle of the Great Resignation and knowing ML at the same time are two really good attributes for you right now, I would say. Anyway, so the basic idea is we observe that this space is a little bit chaotic at the moment, and so there's probably some benefit to being able to speak ML style things to data scientists, ML engineers, product engineers, and also inform them of some of the complexities of dealing with the real world, operationally and so on, and be able to educate the SRE folks, production engineer folks, and so on about what it means to do statistics at a high level and to distill that into a mathematical model and some of the counterintuitive behaviors of machine learning generally and specifically in production.
One of the things I find fascinating about the ML as kind of a software engineering background is that it becomes kind of like a black box. There's an aspect to it where we have this concept of these models, right? And we're training these models, and it's kind of like raising a toddler, right? You can't actually directly control any of their behaviors. You create an environment by which that toddler hopefully comes to love and appreciate your care, but also so that they can learn how to kind of cope with whatever problems they're faced. And I think with machine learning, it's a very similar thing, but you can't really inspect it the way that you can with source code, where you can say, oh, it's this line right here that has the bug. Is that part of the challenge of reliable machine learning?
One way to think about it is that a little bit like the move from kind of stored programs where you couldn't really change what was in the memory of the mainframe or whatever, to a situation where you can write kind of arbitrary programs and have them executed. ML is another layer of indirection. It's saying we will not specify the exact program by which this data will be transformed into the following behavior. We will merely assert that the following thing should take place, and we will leave it up to the mathematics to figure out how to write down that program and execute it. Of course, that layer of indirection unleashes vast potential about how to do things and discover routes to writing efficient and effective programs that humans would probably never discover. But conversely, as you point out, it is all a bit mysterious. It's not very explainable, although there are kind of moves in the industry to move that. There are some techniques you can use to improve explainability and so on. Although I'm not sure that's going to be 100% the case forever, right?
Sure.
But I will say that at the moment it's quite mysterious, and in general people are pretty scared of it, particularly on the operational side. If you've come across this phrase haunted graveyards before, which is basically, oh yes, that system over in the corner, ever since Phil left, we don't touch that system. That kind of thinking also applies to a lot of ML work, or at least abandoned ML work. I mean, The industry and production has not been around long enough for there to be a large proportion of abandoned work, but there's some.
So we're going to see in just a minute here. We're gonna watch a demo of a specific use case. Maybe you can. I know you watched the demo ahead of time. We were both kind of involved in making this thing happen. Can you set us up? What's the use case, and what are we going to see?
So we're going to see a couple of things. The overall framing is a model that helps to estimate arrival time in the case of taxis. So Uber or Lyft or equivalent, basically, when they're popping up the message saying, the vehicle will be with you in blah minutes, like what number should you say? And in this particular case, there's business goals and there's kind of mathematical goals underpinning those business goals. We would like, as a business, to be able to say something like, we will try and complete all journeys within 15 minutes or all round trips or whatever, like some arbitrary expression like that. And then the mathematics of whether or not you are meeting these targets for being able to say to customers statements based on what your model is doing. If you attach an SLO to that, you can then invoke a kind of real-time remediation. In the case of the demo, it's a retrain. For those who don't know much about ML, there's this concept of training over data, which means basically to read in a whole load of data related to the system or product or whatever that you're doing about. And that data is what actually successfully constructs the model. Now, sometimes what happens is the data about human behavior, because human behavior changes enough itself rapidly enough, that data is kind of stale, or you build a model from yesterday's behavior of humans, but it turns out that today's behavior of humans is slightly different in some way, and you experience this kind of drift where the numbers kind of go out of sync with what we want. And the Nobl9 product can attach a kind of automatic remediation to this separation of numbers over time and initiate a retrain, which is to build over more recent data. You construct a new model, you push that model out to production, and then you should see the numbers close up again.
So this is a real, this is a real life example of how ML can be used. And this example of predicting times for a taxi, and I know I've been standing on the corner waiting for my my rideshare to show up, and it tells me 15 minutes and it comes in 22 minutes or whatever. And so this is the scenario from a user perspective. And as you said, it's an arbitrary number as far as the engineering is concerned, but from a customer satisfaction and business perspective, the goal of hitting a certain number is meaningful and might trigger other behaviors too, right? Like promotions for the pricing or things like that. So the time prediction is one use case, but there are probably other use cases that this similar kind of approach could be applied to. Where else, or what are some of the other common ML use cases that require this kind of measurement and retraining?
Yeah, there's a fair bit of nuance to this in the sense that not all model retrainings would result in necessarily improved data. I suppose the canonical example would be mortgage recommendations or whatever. Sometimes you only figure out whether or not it was sensible to do the mortgage recommendation like 28 years after you made the original recommendation. That is not something you were going to resolve by like a rebuild of yesterday's data. So I suppose that's one set of limits to the appropriateness of this technique. I suppose another nuance as well is that retraining isn't necessarily what you want to do all of the time. Retraining brings into scope, typically speaking, data which has arrived since the last time you trained for certain categories. Again, probably I would be reaching to the financial industry for examples here, where you want to build over the interest rate that you guaranteed for this period, rather than kind of huge fluctuations that might be reflective of a very volatile market. Instead of using a webhook to retrain, you want to use a webhook to fall back to a previous version of the model.
So you could look at maybe over time, if the model's getting worse, maybe you want to use a previous iteration of the model
Yeah, and also sometimes you can have algorithmic fallback where instead of performing a huge amount of calculations and so on, you just do a default thing. It's actually pretty useful for that algorithmic fallback to be potentially coupled to real-time situations and conditions rather than being triggered by a kind of guessing code path in the software itself, which only has a very narrow potentially has a very narrow view of what's going on. For example, you have a recommender system in a online web shop of some kind. Normally, the recommender system looks at the user history and goes, okay, you have been reading the following books or whatever, I will recommend these books. User service, username resolution service goes away. Recommender system would ordinarily be kind of flailing around fairly randomly if I can't look up things. So one algorithmic fallback, which is useful, is to just show the top 10 books or DVDs or whatever on the site. And so that won't be too wrong for everyone because those are composite numbers across the site as a whole, but they won't be very useful to anyone. So understanding when to flip into that kind of behavior is potentially
It's
something
interesting.
that could be good.
I mean, part of the use case we're going to see in the demo is triggering actions from specific service level conditions of the ML model, and that might be, like you said, retraining. It might be fallback. It might be, using a completely different, hard coded list. Right. There might be other solutions, or it might be paging the team. Right. If there is no suitable automated answer, it might be page the team to go look at it, which hopefully has happened after a few automated remediations have been tried. What does the world look like without this in place? What's the before? If you have teams today who maybe haven't read your book, aren't familiar with SLOs, aren't familiar with sort of these automation practices, what are people doing in the market right now?
If you don't have automatic remediation, you have manual remediation, and a lot of people spend a lot of time in digging through the equivalent of the entrails of the various models and going, I'm not quite sure what happened here. I suppose I undersell to some extent the sophistication of the teams involved. There's a lot of people who know a lot about machine learning who are working very hard on keeping things going every day. But my sense is in the industry right now, there's kind of a death of a thousand cuts style scenario going on. Yeah. Everyone's got their attention super chopped. There's all kinds of things on fire all of the time. It's not that the economic substitutable good for automatic remediation is manual remediation. It's no remediation sometimes, or prioritized remediation. So my expectation is that the less important things just kind of fall by the wayside. And so automatic remediation is better for the business and almost certainly for the customer or client as well. If you can do something in that space rather than consume the time of the humans for every single thing.
Yeah. Well, there's also in this particular case, and more generally, I would say in software development or delivering software, there's also a question about proper goal setting, and you kind of talked about this a little bit with one of the values of SLOs is defining goals that both take into account the different stakeholders. You have the customer who wants in the taxi example to see a time that's reasonable and accurate, and you have the business who wants to keep customers satisfied, and you have the engineers who want to sleep at night and not get paged, and then also have not get woken up when the system does what's expected by them but not expected by other people. You know what I mean? When it's like, what why isn't this perfect kind of scenarios? And the SLO lets you kind of define those trade-offs. Without SLOs in what you're seeing in practice with machine learning, is there a disconnect about the expected quality or accuracy of the machine learning algorithms? Is this something that today is well understood what those precise limitations are, or is there confusion between maybe less technical or infrastructure or customers about what the ML can do?
One of the great benefits of SLO is kind of the codification on an organizational level of agreements about trade-offs, as you were saying earlier. So if you don't have that, what you typically get is either no agreed trade-offs or very local scope agreed trade-offs. So a particular team will happen to understand the world in a very local way, and they know that team 1, 2, and 3 that they happen to interact with may have slightly different trade-offs, but maybe they've made that local scope thing kind of work okay. And meanwhile, over here, at the very different end of the organization, there's another team which understands the world in a very different way. And you see kind of drift between encapsulated notions of the human experience emerge across a sufficiently large organization, where sufficiently large is probably like greater than two or equivalent, right? So I would say without SLOs, you are either relying on consistency of local scope agreements or models of the world, which generally like doesn't hugely happen. I mean, sometimes you can be lucky, or there's a particularly strong personality or experienced person who sorts it out kind of relatively early on. That can happen, but doesn't happen very often. Or your VP kind of Eye of Sauron model driven, which is the VP reads a story that their trip estimate times are kind of drifting and people are annoyed, and they send a big email with a question mark, a single question mark in it to lots of people, and like the attention goes on that thing and they fix that metric, and that is some sense of encapsulated organizational attention is on this metric, but then the Eye of Sauron moves elsewhere and you don't get consistent kind of output. And again, that's the benefit of the SLO organizational approach.
But part of this is about organizational decision making and decentralizing that decision making away from these sort of high intensity, moments of power, or whether, like you said, like leadership or Eye of Sauron, whether it's coming from different places and probably with good intent, to be honest, right? It's not that somebody's trying to blame or hurt. It's a good intent because they learn about an issue and they want to go audit and dig into that issue. But the SLO presents a way for teams to kind of police themselves and get ahead of this, and also to express very clearly what the expectations are and what they should be, which I think makes a significant difference for especially for larger teams, as you said. I mean, you said teams of size 2, but like for much larger teams, the problem just keeps getting exponentially more difficult for them.
Yeah, and again, bringing it back to the user experience question, it's completely valid for someone to mail Steve Jobs or Tim Cook or whatever and go, the product sucks because a particular set of things X, and whoever it is forwards that on and gets attention brought to it. Like, the world works this way. I'm not gainsaying that. But I am saying that that is a pointillist style approach to the user experience, which is not going to successfully handle anything like machine learning, which requires huge sophistication, not just on a product engineering level, not just on a software engineering level, but in relating together user behavior, business goals, data, huge area in and of itself, and production operations, right? So like the connecting glue needs to be there.
Let's talk about just briefly before we get into the action here in the video. I'm sure many people have already fast forwarded through this part, but that's okay. We'll have one more thing I want to talk about, which is the journey to machine learning, the journey to AI. And what I see with a lot of organizations that I work with is there's a desire in some cases to imbue their software with more artificial intelligence in certain areas, and they may not be ready to do that. And they may have perhaps written checks they can't quite cash yet, and they're using techniques that are less sophisticated because, for all the reasons you just said, they don't have the data yet. Maybe they're in an early stage, they don't have the engineering prowess, etc. One of the interesting things we started with is talking about kind of separating implementation from the interface, and even as a fallback, coming to hey, let's just hard code the top 10 items that are selling right now as the solution. What do you see as this journey of going from maybe hard coded is like the most base example, like we've hard coded the answer to the ML question all the way to using kind of basic statistical data recommendations or other categorization, et cetera, all the way up to maybe Mechanical Turk, and then eventually getting to, and by Mechanical Turk I just mean a person behind the scenes who's curating the data, and then getting all the way up to a true and proper kind of machine learning that's improving over time and getting more sophisticated. Do you see this journey happening, and do SLOs play a role in it? Does this kind of ML ops concept play a role in it, or do people need to fundamentally think differently to do an ML project, or is there a kind of a graduation they can go through in that process?
Yes, again, a lot to potentially talk through there. I think the first thing to say, to be kind of instrumental about it, is SLOs are extremely underutilized in the ML world right now and could be considerably more utilized, which is good news for you and good news for hopefully a load of other people as well. But anyway, I don't think it's a model which most people who are responsible for implementing the first wave of ML systems are hugely acquainted with. I think the second piece is your description of how a team might engage with ML, or an organization might engage with ML and so on, and starting off with hard coding and moving up a spectrum and so on. I don't think that's quite the right model, because in the first instance, a thing which is hard coded is not a machine learning thing, because the level of interaction that I was talking about isn't there. But in particular, the question of changing your behavior based on data isn't there. Now, could you implement a recommender system which simply selects star from products where blah, sort by, group by, blah, 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 and get a recommender system of a kind? Yes, you could. Is that machine learning? Like, no, it's not. So it's hard to get started with machine learning in a way that doesn't bring the full complexity of the situation, or the full complexity of the life cycle of management to you in one go, right? There are use cases which are super simple compared to other use cases, and you should start with them. But whether or not you can avoid kind of the questions related to the entirety of the management of the life cycle, I don't think you can. Or if you can, or if you do, I should say, you're probably leaving alerts and user experience questions and so on kind of going ignored, I would say.
Well, you may so let's take it to a use case, because I think we are talking a little bit hypothetically. So let's talk about the taxi use case, because again, we're going to see the demo in just a second. In this taxi time prediction scenario, right? We're predicting how long till it shows up. Well, before we have enough data, perhaps we have a simple algorithm, which is the average time for bounded to a geography of this, and maybe we can filter it even further and say, oh well, we have trips on these days or at these kinds of times. Not accurate to the conditions that are happening now, and leaving a lot of variables out of the equation. But what it allows us to do is present something, and then it also allows us to collect training data, because now we have we can have the predicted versus actual, or at least collect the actuals, right? Even if the predicted times are not useful because they weren't generated by the model, but at least we're collecting the actuals, and we're giving some base version to of the data to the end user, satisfying their need to see something. And it will probably be wrong and inaccurate. And then over time, then you would take that data and start to feed it into an ML model. And then you could see if that data was more, increasing accuracy over the average, present the average or whatever our algorithm is first. And then once the ML accuracy, exceeds that, then you would flip over to the ML, that process. So it doesn't start at the hard coded scenario. And there may be very limited cases where falling back to hard coded would make sense. Like you were saying, like, the top 10 movies in America might be a good example where you could flip to a hard coded. I think we do see that when you open a new Netflix profile, perhaps. But in these other scenarios where you're really looking at the difference between a simple, maybe a simple average prediction versus a more complex machine learning driven decision, using some simplified algorithm to present some data in order to collect the training data, right? That might be a path on the journey to the ML. Am I understanding it?
I mean, that's not bad. There's a huge variety of things you can do, which will help you to collect data, which is, of course, the primary thing that you'll need to do in order to construct a model. But the point you actually made with respect to, well, the model didn't make these predictions, so we're not comparing prediction with actual, is kind of true, actually. For the purpose of creating a model, rather than taking some mathematical average of the number of trips within the locality minus a traffic congestion penalty for a particular time of day or whatever. You will only get somewhere if you bring the model into the equation and the training over the data and so on and so forth. But yes, you can refine almost anything over time to be more accurate. It's a question of resources, additional data, sometimes probably much less than we assume in the ML world, the choice of the algorithm you use, hyperparameters, which are these things that describe how many iterations you will train over and what kind of configuration you will use for those iterations, so on. So yeah, there's a huge amount to this. And coming back to your larger point, yeah, actually, maybe the end of the spectrum that you start at is not hard-coded return true, but is something which is a bit more sophisticated than that, and that gets data in the door. Yeah, absolutely.
Okay, awesome. Well, let's leave it there, and we're going to transition now to the demo. Niall, I want to thank you so much for chatting with me today, and I'm very much looking forward to your book coming out.
No worries.
Hi, everyone. My name is Nader Mortazavi. I'm a solution engineer at Nobl9, and today I have a couple of experts in machine learning that we're going to discuss how machine learning and SLO work together to understand how machine learning principles and SLO connect. So my question to you is, Wade, why do you think the machine learning systems requires SLOs?
Yeah, so to answer this question, I will show you a few slides so that we understand each other perfectly. So first, machine learning models are very complex by definition. They depend on many things, and the most important are business, data, mathematics, and engineering. So to have all this together managed, you need to special approach for that. So machine learning models are mathematics. This means you live in two worlds. So business thinks of business performance measures, business success measures, business goals. But when you build a model, you go down to a very, very formal formulas, and you have to monitor both sides. Second, machine learning models, in fact, don't exist. What you build automated pipelines that generate instances. Very concrete machine learning models. Very concrete instances generating during the time and on different data sets. The next challenge is when you build a model that forecasts or predicts anything, to calculate the performance, you really need to take into account a very unnatural for human being delays. So when you forecast demand in 2 days ahead or churn decision in 6 months ahead, only after this time you can say if the model was correct or wrong. The next thing is that machine learning models depends on data that is changing in time, and this means that models built today in next future will be of lower performance. So you have to understand this, and you have to find the moments where the model's performance deteriorates at the level you are not accepting. So having this put together, I find SLOs important for machine learning because you can monitor all aspects of machine learning models in parallel and make this actionable. Okay, so this is make this actionable. So let's get back to this one. So you monitor machine learning models at all the aspects and make this actionable. This is depicted on the slide. So you calculate the raw measures, put them into a storage, and then there is a question how to make automated closed loop or feedback loop that helps you manage the models at scale.
Thank you so much, Whit, for going over those principles. They sound very interesting. And now I want to bring up Maria, who is a data scientist at 1433, to go over a taxi rides use case for us. To you, Maria.
Yeah, thank you, Nader. I will go through the taxi rides case, as Nader said. And we all know that today's taxi companies have mobile apps which can tell us the estimation of the taxi ride, because it's crucial for customers to know when they will be, if they will be on time or not, and how much the taxi ride should take. So we can have multiple SLOs and their types. And first one is business SLOs, and it tells us how big is the error in minutes between time travel estimation and the real value. And the other one is ML SLO, and it tells us how much the error exceeds 1 standard deviation, 2 and 3 standard deviations. And in the view of high-level architecture, it's like we have a Nobl9 product which is monitoring. We have a target and scores values, which comes from, in our case, from BigQuery. Then it goes to the Nobl9 product, which is meant for monitoring it. And the Nobl9 can trigger retraining if it's time for it, when the data, for example, deteriorates. And when the model is being retrained, it can be reused for serving, redeployed for serving, and then the path continues. And I will go now to the live demo and show you the product in real use. So here I am in the Nobl9 dashboard, and we can see here our defined SLOs. And the first thing I did here in the Nobl9 product was integration with BigQuery. We can have a bunch of different data sources connected, and I chose BigQuery one. And now I will go to some demo part for this our taxi use case. Here we can see a dashboard for error deviation. We can see that most of times the error deviation was about 1 or 2 times standard deviation, and here it goes smooth. This value don't go up too much, but then we can see that the standard deviation from the average was getting worse, and it was getting worse a lot of times. So it can indicate that the input data has changed. For example, there was there were roadworks in the city center, and it had impact on the duration of taxi rides. We can see in the wider view that this metric dropped here, and this is the time when we alarmed for the model retraining, and then we had to wait for the model to be retrained. And here is the point in time that we stopped retraining the model and we redeployed it. And we can see that the metric was on the same threshold for some time, and it means that it stopped decreasing. So the model was started working good once again. And in the wider perspective, we see that the metrics got back to their standard level. And on the other hand, we have this business metric, which shows us that the model wasn't wrong many times. The error wasn't above 2 minutes. The most of the time the error was lower than 2 minutes. Yeah, we can see it here, and there we have this data change, and we can see that error started giving more. The error that the model was giving was larger, and we can see it also here, that the threshold that this value was decreasing, but it didn't reach the threshold that we set. So from the business point of view, nothing bad happened, and we managed to detect the change and react quickly for this change, and the metric is good all the time. And for this, like the second, yeah, I think I can stop there. Now I can show you how to make an alert. So we can go to integrations and add an alert method. And here I have created an alert for retraining and used a webhook. I will show you now. We can also get a bunch of integrations, and I have chosen webhook here. And when we have an alert method, we can add the alert policy, and it's done in this tab. We can click here and define the policy and add a name, and here we can select our webhook created earlier.
Well, thank you, Maria. That was very, very wonderful. So what you showed us here was the way that your team is using Nobl9's platform to monitor the way that your taxis are staying true to the machine learning model that is defined for them. And what you showed is that you have both business and technology metrics around those two use cases. And once any of those thresholds on the reliability burn down goes below and you consume your error budget, you're automatically using webhook to retrain your model. So we're really working towards automations and minimizing the actual manual work around this. And that's where Nobl9 platform comes in very useful for the machine learning products.
I wanted to say that the common pattern we observe when we are monitoring and maintaining models is that business alerts are not always reached if we have good alerts on technical measures, as it was shown in the demo. We believe and we see a great benefit of using Nobl9, which by automating our maintenance work can help us manage many models in parallel.
Well, thank you both for your time today. And I want to highlight that Nobl9 is helping companies such as 1433 and the ones that are using machine learning in their platforms to bridge the gap in between monitoring your actual data model and automatically retraining it when it's needed. Nobl9 platform is currently available, and you can go to nobl9.com/hydrogen and start a new trial and try the product for yourself. Let's say hello.
Introducing Hydrogen.
If you run a business,
from Nobl9,
you know that 100% perfection,
the first tech debt optimizer designed to prevent burnout,
especially at scale.
Optimize velocity,
more complex your business
help you stay focused on what
less
matters.
likely it is to be perfect.
Find the right pulse for your team and for your customers.
Problems immediately.
Hydrogen.